Okay, whilst watching this video, make notes, make sure you've got a pen and paper nearby. Listen again. If you do need to rewind the video, do so just to make sure that you get all the points you need to hear. Be prepared to pause. There will be certain points of this presentation where I will ask you to pause to have a go at an activity. Please do the activity, and then obviously you can see whether you need to skim through a little bit quicker or not. And finally, try to avoid distractions, so don't have your mobile phone close by, likewise with music or TV. Okay, so this tutorial is on exact trig values, and we're aiming to be able to recall exact trig values for sine, cosine and tan theta. Now for this you need to have some prior knowledge of trigonometry, so remembering the trig ratios, and I remember that via SOHCAHTOA. Drawing the two triangles that identify exact trig values, working out exact values of sine, cosine and tan theta, and then looking at calculating some missing lengths. Okay, prior learning then, we need to remember the three trig ratios. Remember, when we're looking at sine rule, we are looking for the opposite and the hypotenuse. So I may be given the opposite and looking for the hypotenuse, or vice versa. For cosine, this involves the adjacent and the hypotenuse, so Ca. And then finally tan involves the opposite and adjacent sides, and that's TOA. Easily remembered by that, SOHCAHTOA. Another thing you'll need to remember for this lesson is how to rationalise the denominator, and they will be fairly easy ones. Okay, so in the case of this question, when I'm asked to rationalise the denominator, what the question's actually asking me to do is to get rid of the irrational denominator, that being the bottom number, because that's a surd, and make it into something rational, so something that's not in a surd sign. In order to do this, all we do is multiply the top and the bottom by whatever the denominator is. In the case of this example, it's root 5, and simplify. So I end up with 3 root 5 divided by root 5 times root 5. Remember, when you multiply a root that's the same by itself, we end up with a rational number that is that number. So in the case of root 5, just becomes 5, because root 5 times root 5 is root 25, and the square root of 25 is just 5. Okay, that will be the extent that you need to rationalise the denominator for this lesson. Now, what we need to know today is the exact values of sine theta, cos theta and tan theta, and theta will be 0, 30, 45, 60 and 90 degrees. Now, there's two methods. I'm going to do the second method, but if you want to have a go using the exact trig values hand trick, you can Google that. There is a link on the bottom there if you want to try that method, if you think that might be a little bit easier. Now, I'm going to go over sine, cosine and tangent for 0 first. Okay. Now, to do this, I use this really simple diagram. It's called a unit circle, and it shows the radius of 1. Now, because we know the radius is 1, we can directly measure sine, cosine and tangent for 0. Now, this might be a point where you want to make some notes. In an exam situation, this would be on a multiple choice question. So you would be asked to give the value for cosine 0, for sine 0 or for tangent 0. Okay, I'll explain the method just so you understand why it is. Okay, so in the case of cosine 0, remember SOHCAHTOA, or cosine is a divided by h. Okay, so that in this case would be x, because that would be the adjacent side. We don't know it, but we know the hypotenuse is 1. So we'd be looking at x divided by 1 multiplied by cosine 0. That's the angle that we've been given. If you stick that in your calculator, you get a reading of 1. Sine 0, okay, so remember sine from SOHCAHTOA is opposite divided by hypotenuse. Well, again, we know the hypotenuse, that was the radius of 1, but we don't know the opposite side. So if we was keying that in, we'd say x to represent the opposite side divided by 1, which was the hypotenuse, times sine 0 gives me an answer of 0. Finally, for tangent 0, remember that's opposite divided by adjacent, so we're looking at x divided by 1 times tan 0. That also gives me 0. Okay, so remember it would be a multiple choice question, but we don't want to miss that one mark. Now for sine, cosine and tangent 90 degrees, so in other words, we're imagining we've got 90-degree angle given. Remembering SOHCAHTOA again. So for 90, cosine 90, sorry, we're looking at the adjacent divided by the opposite side again. So again, we're looking at x divided by 1. Remember the 1 being that radius that we've been given, which is the hypotenuse in the case of cosine 90, times cosine 90 gives me a reading of 0. For sine 90, which again, remember, is opposite divided by hypotenuse, we're looking at x divided by 1, the radius, times sine 90. So this is all you're just keying into your calculator, which again is 1. Now, you wouldn't get this on an exam. Okay, so in the case of tangent 90, which is opposite divided by adjacent, when you key that into your calculator, you'll get maths error because that's a reading that is undefined. Okay, so for the two on that page, try to remember and revise cosine 90 being the value of 0 and sine 90 being the value of 1. Now, the method I use to find exact trig values is using the triangle method. Okay, there are two triangles that you're going to need to remember. Now, the first thing you need to do is to draw an equilateral triangle and remember its dimensions. Okay, so it's 2 by 2 by 2. It's an equilateral triangle, so each of the angles will be 60 degrees, and I'm going to split it in half. Okay, now the angle at the top there, because I've split it in half, would now be 30 degrees. So I've got the hypotenuse, I've got the base, which all of that is 2. I've cut it in half, so it's going to be 1. And I need to find that side that's in the middle. Okay, so the line that goes straight up the centre of the triangle. In order to find that, I would use Pythagoras Theorem. And that says 2 squared minus 1 squared would give me the square root of 3. Now, because we're dealing with exact trig values, we're going to leave that as root 3. So you need to visualise that triangle. You need to remember that triangle. Okay, so we've got an angle of 60 degrees at the bottom, an angle of 30 degrees at the top because we've split the triangle in half. The hypotenuse is 2, the base is 1, and the side is root 3. Now, we're going to use this triangle to calculate angles of 30 degrees and 60 degrees for sine, cosine and tangent. Okay, go back a bit. So for sine 60 degrees, so sine, remember, that is opposite divided by hypotenuse. So if I go to the angle at the bottom left, which is 60 degrees, and I look opposite, I can see root 3. The hypotenuse is 2. So sine 60 is simply root 3 over 2. Cosine 60, again I'm going from the bottom left angle for 60 degrees, and I know that cosine is A divided by H, adjacent over hypotenuse. Well, the adjacent side to 60 degrees is the 1 and the hypotenuse is 2. Finally, for tangent 60, again going from the bottom left angle of 60 degrees, I'm looking at opposite, which is root 3, divided by adjacent, which is 1. If you want to write root 3 over 1, that's fine, okay, but root 3 would be better. For sine 30, I'm going to go to the top of the triangle and I'm looking at 30 degrees and I'm looking at what sine is, or sine's opposite divided by hypotenuse. So sine 30 would be looking at 1/2 because opposite 30 is 1 and the hypotenuse is 2. For cosine 30, again, I'm going from the top of the triangle and I'm looking for the adjacent side and the hypotenuse. Adjacent to 30 is root 3 and the hypotenuse, again, is 2. So cosine 30 is root 3 over 2. Finally, for tan 30, tan is opposite over adjacent, we're looking at 1 over root 3. Now, the reason I mentioned about rationalising the denominator, you'll see the answer to tan 30 actually gives me an irrational sort of value in the terms of the denominator is a third. Okay, in order to get rid of that, all I'd need to do is multiply the top and the bottom of that fraction by root 3. So that gives me an answer of root 3 over 3. Okay, so that was the first triangle. Now, the second triangle you'll need to remember. So there's only two to remember. Okay, so the first one was your equilateral triangle. The second one is a right-angled isosceles triangle. And you just need to remember the side lengths, which is 1 and 1. Now, because it's a right-angled isosceles, each of the angles that are missing are obviously 45 degrees because it's an isosceles. The hypotenuse to this triangle would be root 2 because, again, if I use Pythagoras' theorem, that would say 1 squared plus 1 squared would give me root 2. To find the three angles for sine, cosine and tan 45 then, if I look at sine 45, well, I can go from either the bottom 45 degree angle or the top one because each of their side lengths are both 1 because, as you know, the length of the side, it's basically equivalent to its proportional angle. So we've got 45 degrees, so we end up with 1 over root 2. And again, you can see we've got that problem with that irrational denominator. So we're going to rationalise the denominator again, multiplying the top and the bottom of that fraction by root 2. So I end up with root 2 over 2 for sine 45. For cosine 45, remember cosine is A over H. And again, from either of the 45 degree angles, I'm looking again at 1 over root 2. Again, rationalise the denominator to get root 2 over 2. Finally, for tan 45, I'm looking at opposite over adjacent, which is 1 over 1, which we just write as 1. Okay, at this point in the video, if you have made notes, can you turn your notes over and I want you to have a go at copying this table and filling the values in. If you don't need to use the triangles, try not to refer to them. Okay, if you do, obviously use them at the top. For the angles of 30 degrees and 60 degrees, remember you're using the left-hand triangle, and for the 45 degree angles, you're looking for the one on the right. Okay, if you manage to do that activity, these are the values you should have with all the values in terms of rationalised denominators. Okay, you might be asked to find exact values using your understanding of exact trig values. Okay, so I'm going to go over an example question for you and then I'm going to get you to have a go at a couple, again pausing the video. So we've been asked to find the exact value of the missing length x. I've been given a triangle with an angle at the top of 30 degrees. If that angle at the top is 30 degrees, the side opposite to it is opposite and there is no information there. That means that x must be adjacent and the 8 must be the hypotenuse because that's opposite the right angle. So I know this involves cosine because the two bits of information are A and H, which is ka, so, ka, toa. Okay, so this involves cosine 30 is equal to x over 8. I'm going to substitute in the value of cosine 30, which, if you go back to your table, you know that that's root 3 over 2. Now I'm trying to make x the subject of this formula, and at the minute I've got x divided by 8. Remember the inverse functions, when I need to get rid of a divide by 8, when I move it, it will become multiplied by 8 on the opposite side. Okay, so x is equal to 8 root 3 over 2. I can make that a little bit better. Okay, the 8 and the 2 I can divide to get 4 root 3 is equal to x, or x is equal to 4 root 3. Have a go at this question. Again, look at what information you have in the diagram. Okay, work out which bit of information you need to substitute in and solve for x. Okay, the information on that one then, so we've been given an angle of 45 degrees and we've been given the side opposite to it and the side adjacent to it. So we know this involves tan because it's TOA. Tan 45 is the angle and that is equal to 5 over x because it's O over A, opposite over adjacent. Remember, I'm trying to solve for x here. I know this value of tan 45 is 1 because I've just worked that out in my table. So now I'm just trying to solve for x. If I move the divide by x, which is on the right-hand side, to the left-hand side, that ends up being 1x or x. So the value of x is 5. And we didn't really need to work that out because we know that that bottom angle there would also be 45 degrees. Its length would be the same as the other one. Okay, one more question for you to have a go at. Okay, so for this one, we've been given an angle of 60 degrees and opposite it is x. And there's also the hypotenuse given there, okay? So I know this is OH, which is sine 60, okay? And I'm going to substitute in the values I know. So the opposite is x and the hypotenuse is 5, so it's x over 5. The value of sine 60 is root 3 over 2, and that is equal to x over 5. Remember, we're solving for x, so then all I need to do is to move that divide by 5 on the right-hand side over to the left-hand side next to the root 3. So my final answer on this one would be x is equal to 5 root 3 over 2. We can't cancel the 5 and the 2 down because they've got nothing in common other than 1. You may be asked to put your understanding into one of these slightly wordier questions. Okay, so we need to show that the value of cos 30 times tan 60 added to sine 30 is an integer. In other words, a whole number. This is a 3-mark question. Again, if you can pause the video and give yourself 3 or 4 minutes to see if you can get the correct solution to this question. Okay, so the 3 marks from that question come from, and I will keep flicking backwards and forwards. Okay, so root 3 over 2, well, that's the value of cos 30, and I'm multiplying it by root 3, which was the value for tan 60. I'm adding it to a half, which was the value for sine 30. Okay, so that would be for your first mark. Root 3 times root 3 would give me root 9, which is 3 over 2. And I'm adding that to a half. There's your second mark. 3 over 2 add a half, okay, would end up being 4 over 2. And 4 over 2 is equivalent to 2. So if you gave your answer as 4 over 2, technically that's incorrect because we're going to need to give our answer as an integer.